from the early stages, it was obvious that there were some problems. For example, in 2013, we had Google using autocomplete and using inappropriate suggestions for queries like women need to, and you can see some of the results. So this was one of case of gender bias in platforms like Google Search. Then we had automatic translation, which we already mentioned. So we have translation from Hungarian, which is a language that has neutral genders. And we see that nurse is associated with a female, while a scientist or an engineer is a male. Then we have searching with keywords for images, which is a classic example where we see that a doctor is a white male guy, while a nurse is a female. Also, searching about CEOs usually retrieves images of men, white men, Western culture. Right? So there are a lot of biases we can understand. Even in the work back, which is the model I told you that was able to somehow capture the context of the words, we can see in the space, the mathematical space, that some words, the words like man and he are associated closer, so they are more similar with words like computer programmer and architect, while a woman or she, they are more closely related to a homemaker or a hairdresser. So we can see the bias even in the embedding space. In 2018, we have news that showcased that Amazon was using a tool as a way to, as a recruiting tool, an AI tool, as a first filter to cut CVs, because they get a lot of CVs, they were trying to use an AI tool. This AI tool, because it was trained over data from 10 years, which were about men, just cut every CV that contained the word women. So they had to take it back. And even today, after all of this work, this is something that I did a few days ago. I used DeepSeek. DeepSeek is probably you have heard about it. It's the trendy LLM right now. So I asked DeepSeek to write a story about a nurse. The interesting part about DeepSeek is that it follows a specific approach which is called chain of thought. So you can see what it's thinking to produce, to generate the text. And what we see is that for a nurse, she is Clara. So still we have ways to associate nurse with a gender. And not only that, but it also shows us that Clara has sentiment and feelings that are usually associated with women. So she's probably she's loneliness, past losses, etc. So there's words associated with sentiment that somehow is stereotypically associated with women. On the other hand, afterwards I asked about the CEO story, so we have a man that also is called brilliant and untouchable. So many characteristics. So why is this happening? In order to understand why this is happening, we have to understand how these tools are trained. So we have to see the feedback loop of AI, of statistical AI. So everything starts from the data. We have the data, we can have any kind of data. They can be videos, text, interaction with some graph, social graphs, etc. Or even annotated data from humans, etc. So these data are then passed through the algorithms and the models that are trying to somehow optimize their performance based on this data. And then they produce the output. The output can be any kind of output. We can have filtering algorithms, classifiers, rankings, or even a generation of any kind of text, images, whatever. And this output is then given back to the user. And the user then interacts with this content and provides new data, new interaction with this data, which are then feedback again to the training algorithms to improve this cycle. But this feedback loop of AI is also the vicious cycle of bias, as we call it. Why? Because the data we use are unbalanced. They have unbalanced representations of the different protected groups and also include various historical stereotypes. And then we have developers that unconsciously add biases in what we develop. For example, from what parameters they are going to train their models, or even what datasets they are going to train their models. And then we have the output that, because it is optimized to work well with this data, reinforces and amplifies all these biases and stereotypes. And then we provide all this amplified bias data again to our users, who are going to continue all this vicious cycle as we call it. And we miss all these other people. So AI, we can think it as an amplified mirror of our society. Gender bias is just one kind of bias. There are many biases: racial, ethnic, religion, age, etc. But we also have a lot of, our world is full of unconscious, systematic cognitive biases, like confirmation bias. We want to search for things that we already know and we support. We are not going to search for things we don't know or we do not agree with, which will lead us to a state which is called cognitive dissonance. Or homophily, we are with people around us that have the same opinions with us. So these are studied in psychology and sociology, and they affect our judgment and decision making, and they lead to echo chambers and filter bubbles. And also, we should never forget that there are also other ethical issues associated with AI and online platforms that use deep learning, including hate speech, bullying, disinformation, misinformation, and privacy. So, how we can measure bias? Generally, the community has provided a number of different definitions of fairness, for example, group fairness and representation fairness, which is used for classification metrics, where the idea is to classify things independent of a protective attribute like gender. Then in text, we use various metrics based on probabilities or distributions or embeddings, the vectors in the multi-dimensional space I mentioned earlier. So we can ask an LLM, if it's open, we can ask an LLM the probability of filling this sentence. So we have a teenage girl, and we ask it, what is your favorite course in school? And the LLM has to provide us with different probabilities for the different values in the set. So we want to see whether the LLM will provide stereotypical probabilities for a girl, for example, she will probably be interested in leadership. Or we also check out for co-references. So we have a secretary that called the physician and told him or her what the LLM believes. Also, we have metrics about clustering and community detection. So the idea there is to provide clusters that do not misrepresent different protected attributes like gender. And finally, we have network analysis metrics. These are metrics that try to identify influential nodes in a graph. Consider, for example, a social graph. So the important nodes should include, or at least have a specific threshold probability to also include nodes from a protected group. Now, about mitigating bias, or as we call it, biases. There are three main approaches. The first one is the pre-processing approach, where we mainly focus on the input. So the idea here is to somehow balance our data sets, filter out outliers that are biased, provide synthetic data for data generation or instructions for prompts for the LLMs. This presupposes that we can retrain our models. This is not always the case, because these models are really expensive to train. Also, there are in-processing approaches. These approaches, we modify the model itself. So we might add the bias equalization objectives to the loss function that this model is trying to learn and optimize. Also, we might identify specific nodes in the network that are biased. And finally, we might fine-tune the models using adversarial learning or a human as feedback to optimize and align based on our ethics. Finally, there's another approach that considers that the AI model and algorithms is just a black box, which is the most common if we are Google, Meta, etc. Where the idea is that we change the output, so we rank things, we enforce some constraints, etc. So concluding, this is an ongoing battle. everyone has a role to play. Researchers, they have to ensure that fairness isn't an afterthought, but it's the foundation. But this has to be done without sacrificing the performance of the models and the algorithms. We need to make things transparent so we know how they work and why they produce the results they produce. We have to create balanced data sets, more bias metrics, and also other mitigating approaches. Also, policymakers need to provide legislation, and we need to audit all these online platforms so we know what they are doing and if they are doing something on purpose or not. And they should be accountable about any kind of bias that they propagate to our society. And finally, users, which for me is really important because whatever we discussed right now was about algorithmic approaches and how we can do things behind we don't have the user in the loop. So we have to provide tools to our users so that we can encourage awareness, critical thinking. They have to know that what they read online is probably generated information and it might contain biases. So they should try to find and use diverse information, etc. So this is something that we have to work on. So closing, what I have to say is that AI right now reflects our biases. We should make it to reflect our values. This is an AI-generated image. I provided a prompt, create a mirror with inclusive mirror of different protected groups, etc. But you can see there are no aged persons, no people with disabilities, non-Western cultural people, etc. That's all.
So George, your turn. Have you uploaded your?
No, I Okay, thank you. My name is Giorgos Giannakakis, and my presentation is about promoting inclusion, diversity, and non-discrimination through educational software. I will outline some social and political context about inequalities. The United Nations of 2030 Agenda for Sustainable Development report concludes that income inequality is getting worse. 71% of world's population live in countries where inequality has grown. There is an example of income in North America is 16 times higher than that of people in Sub-Saharan Africa. The same picture also occurs in Europe. The income gap is great between the north and the south part of Europe. And finally, it adopts the principle that leave no one behind. The link is provided. The same picture can be observed to the reports of Organization for Economic and Cooperation and Development, that they report that the income inequality rising in the last 30 years. This is reported in many OECD reports. The middle class has been squeezed by rising costs. There is a sharp increase for refugees and asylum seekers in 2022. There is a report saying that there are 31.6 million people asking for asylum, and artificial intelligence labor market shrinks the demand for medium-level skills, but there is a demand for high and low-level skills that cannot be automated. And this leads to job polarization and job losses. This will be more intense after the US elections results. All these social, economic, class, cultural effects are expressed and demonstrated also in education. There is educational inequality. The OECD again, Equity and Inclusion Educational Report, reports what expressed in the previous inequalities. Socioeconomically privileged students outperform non-privileged ones. This has been reported in PISA 2018 report. There is a reading gap in favor of girls in all OECD countries. And the larger gap for students is in the 10th bottom income percentile. Again, there is a social factor. And there is a reading gap in favor of native students compared to immigrant students. There are 4 types of educational models. There is the exclusion model, when the students are directly or indirectly prevented from access to education in any form. There is the segregation, which occurs when diverse groups, it's the first one. The segregation, the second figure, where diverse groups are educated in separate environments. The integration is the third figure, is when students with diverse needs are included, but are integrated in the educational process. And finally, the inclusion that helps to overcome barriers limiting the presence, participation, and achievement of all learners. This is the link. And of course, the inclusive model is considered to be the most appropriate. This is not a new concept. It has already been adopted as educational policy from UNESCO according to the Declaration of 1994 in Salamanca. There are key factors of inclusive education, promotion of student participation and reduction of exclusion, the presence, participation and achievement of all students, especially those who are excluded or are at risk of marginalization. And there is a guideline according to what is inclusion and what is not. I just point one point that inclusion is about benefiting all learners and not only targeting the excluded. And what is not inclusion is responding only to diversity, but not improving the quality of education of all learners. This can be, we can define some diverse student groups. It's students with special educational needs, immigrants and refugees, students belonging to ethnic groups, national minorities, social minorities, the gender factor, and the LGBTQI plus students. Eliminating inequalities in education is a multi-level approach in individual, social, and institutional levels. Some points is to related to education and awareness, equal opportunities, especially where inequality exists, like STEM for women. Rising awareness at an early age, like the primary school or the high school. Awareness campaigns and communication strategy, legislation and policies, enhancing legislation and provide policies in order to fight discrimination, and changing social norms and stereotypes, combating stereotypes, or engage some groups in this process, like engaging men in gender equality. It's considered to be a good practice. Bridging the gap. Digital technology can help make education more equitable and inclusive, can assist diverse students groups to reach their potential academically, and provide a better equity in educational access. As a use case, we will present a project we coordinate here at the Institute of Computer Science in Fort. It's the STEAM DAI, Diversity in STEAM. It's under the program of Erasmus+, under the action type of cooperation partnership in school education. Here is the link where someone can find more information. The project aims to empower diversity and inclusion in school education utilizing the STEAM frame educational framework. STEAM is the extension of STEM, means science, technology, engineering, and mathematics, but extended with arts, with aid and arts. Promotes equality, non-discrimination, such as special educational needs, LGBTQI plus groups, social minority students, and create innovative, interactive, gamified, technological advanced curricula to support diversity and inclusion in education. Which are the results? Full educational curriculum for the use of the project, 3 films, 3 digital films on diversity. They were trained and directed by the well-known director here in Iraklio, and 3 educational software, Maths to Cubes Painting, the Mirror of Diversity, and the Collective Face. The latter 2 were developed here in Forth. Regarding the Mirror of Diversity, the concept is that we are all members of humankind and what somehow variation of humankind. So by chance, we were born in Greece and not in Nigeria or in Japan. And I will also add, by chance, we were not born in Ukraine or in Palestine, or we were not in a hospital that was bombed. And by chance, we have a specific gender. So if we understand that we are all variation of the humankind, there is no reason to discriminate, to bully, or have this kind of behavior. So this is the idea. And the application is like the mirror on the wall. How would I like if I was coming from Africa? So we created a software in order to provide this. And how would I look like if I was a girl instead of a boy? The application has the form of a virtual mirror. It transforms the participant face to a face of different gender and different race. There are models from Asia, Africa, and North Europe. And this is the setup. So what is the technology behind this? We change the facial characteristic in terms of facial geometry, utilizing 3D facial statistical anthropometric models from different races, like from Africa and Asia, and projective variation utilizing the LSFM models. And also we change the texture, identify facial regions using automatic facial landmark estimation here, and change the facial texture utilizing the facial GAN. Here is an example. My colleague Vivi. We ran this project with Vivi Balegraki and Tassos Roussos, and this is an example of Vivi transformed to a man from Africa. The second application, the collective face, a face that will combine the facial characteristics using automatic computer vision methods. So it would be a symbol of the face of the humankind. We use this for the collective face of the participants of this project. This is the technology behind this. I will skip it. This was the design phase of the software. Just a comment, we use the round table with all stakeholders, trying to not to be all the white men people that are discussing in research for creating a software. We just used students from LGBTQI plus community and women and etc. Some limitations of the project. It is limited to a small portion of the total student population. Only 35 European students took part in. There is a difficulty in including the project results in the main educational curriculum, and it's questionable the effectiveness of this project in changing policies. Why equity and inclusion in education matter? Because it provides benefits for all students. improves the quality of education in general, better student outcomes later in life. They create active citizens fighting exclusions, fosters students' socio-emotional growth, and improves societies. What finally matters? The protection of human rights, equity, and fairness, where in education, workplaces, and society. Thank you.
Prof, you said protection of human rights,
Equity and fairness.
So greetings everyone. Today in the context of the workshop for gender dimensions and generative AI algorithms and video synthesis, I will be presenting the mirror of diversity tool, which was mentioned by Jonas earlier, and it was developed in the Erasmus Plus project Springtime. And it was also presented with a lot of participants and researchers tonight, as well as in the hackathon of Springtime project. So beginning with the objective of the project, it aimed at developing a robust system for real-time 3D face manipulation. As shown earlier, here you see a specific example of transformation, where the face is altered, in this case, to a male from Africa. On the left, you can see the original video stream. On the right, the manipulation. We wanted also to combine GANs for texture synthesis with the 3DMMs and 3DMMs for geometry manipulation. It was essential that we preserve the identity features and transformations so as to be realistic. And the ultimate goal was to enable diverse face transformations across multiple ethnicities and genders. The motivation actually stems from the apparent lack of tools addressing realistic ethnicity-based transformations, the promotion of diversity and inclusivity through interactive installations. Also, this tool could be used to facilitate conversations around culture and identity, and it would allow students to see themselves as well as others in different representations and various ethnic transformations. So it has applications in education, in digital art, psychology, and neurosciences. Some of the key contributions was the development of mirror diversity software, which allows users to experience realistic transformations of their faces as if they were of different gender or ethnicity. The innovative use of AI and specifically GANs to explore the personal and cultural identity. From a new perspective. Actually, this was because we wanted to answer the question whether AI and computer vision could be used to help us approach the issues of inclusion. The introduction of collective face feature, which highlighted that despite our ethnic or gender differences, we all as humans share the same common human essence. The use of state-of-the-art methods like large-scale facial models to create the realistic transformations, the engagement through a virtual mirror, which was interactive, as will be shown later, and the educational impact, which was of paramount importance as well. Some of the results now, the methods. Actually, the method I want to show here, the installation setup, which consists of a ring light. The ring light was used in order to ensure the consistent lighting for the texture sampling process. A simple camera, two monitors. The first monitor is the monitor that the user can see. It is a 3D graphics window where he or she can see himself through as if the users were of different nations or different genders. And the second monitor is the monitor of the instructor, where in this case I can see the GUI and the camera feed. And now I have a video where all this pipeline is actually shown. The installation setup, as I said earlier, the participant sits in front of the camera and the ring light, and the monitor in front will be the graphic window representing the transformations. The calibration phase is actually a technical detail where the instructor takes 5 frames of the participant. And then we have the facial reconstruction in the 3D graphics window. As you can see, the facial reconstruction with the texture appears in the graphics window. It follows the movements of the user in real time, both in scaling and rotation as well. When the instructor presses the marble statue button, then the facial reconstruction will appear as a marble statue. That means only with the 3D shape. And here we can see it for another participant as well. There are multiple demographic transformations. The user chooses from the paper that displays all of the possible transformations. And then, in this case, from female to male, it was the transformation. Once the user chooses, then the instructor presses the button from Choose Your Reflection menu over there. And then, in this case, male from Asia, for example, transformation with 3D shape and texture appears. Or same as before, if I press the marble statue, it can only appear with the 3D shape form. Another utility, another functionality is morphing effect. This was actually functionality which we added because we wanted to show the gradual shift from the original face reconstruction to the target desired transformation by the user. And I will show some more examples, more transformations here. We have a female from Africa. The morphing is pressed, so you can see that it changes in the 3D graphic window the rendered face. Also, we have a male from Asia. It is a female participant and transformed it into male from Asia. The same with the marble statue view of the target demographic. Also, here morphing effect is also shown. And now about the collective phase. Once the instructor presses the Send to Collective Phase button, then the collective phase code, which runs in another machine, communicates with this, and the user's identity coefficients are sent. You can see that it has this effect, it goes back, and when the mesh approaches the user, the averaged phase representation is computed. It works actually as an averaged facial identity of all the users that have participated, and you can have a closer look here. Now we'll be mentioning some conclusions. We developed mod software that supports multiple gender and ethnicity transformations. The participants at the hackathon and research have praised the tool as innovative and recognized this promising tool. We are planning to expand gender transformation capabilities in order to include non-binary and gender fluid identities. Thank you for your attention.
Can I say something?
Sure.
This is really very innovative. I never saw something like this. Congratulations.
So following from this talk, I'm Tassoulos. I will talk about some additional gender aspects in generative AI for image and video synthesis. And let me start with a video. This corresponds to a breakthrough moment in generative AI that happened about 1 year ago when OpenAI released results of its text-to-video generator, Sora. So the input in this model is just the text that you see at the bottom, and the result is a very photorealistic video of very impressive quality. And even for researchers working in the field, it was really astonishing the quality of the results, and also the fact that this video is so temporally consistent. So how did we get at this point? So the roots of this development can be traced back in the developments of AI. So based on the big success of deep learning in both image analysis and text analysis, scientists started experimenting in bridging them, trying to combine image and text representations. So in 2014, we had the first AI models that were able to solve the task of automatic image captioning, as you see on the right. So they were taking us into an image, and they were giving us out the text description of the image with impressive results, with captions that most of the times made sense. So soon after that, several scientists started working on the inverse problem. Instead of image to text, actually solving the text to image generation, which for several reasons is an even more challenging problem. And in 2021, we had the first successful models, and soon after that, other models emerged. For example, DALL-E, Mid-Journey Stable Diffusion. I'm sure that you all have seen many results of this kind in the internet. So the results attracted a wide interest in public discussions. And during the last years, such systems have become available to the general public to use online. And actually now, internet is really flooded with such synthetic AI images. So it's characteristic that as a study from 2023 revealed, AI had already created as many images as photographers had taken in 150 years of photography. So we're talking about 15 billion synthetic images, which is a really huge number. So all these developments have several aspects of impact. First of all, several aspects of positive impact, such as, for example, in visual arts, painting, design, and filmmaking, in terms of actual democratization of the artistic means, as well as novel means of artistic experimentation, as you can see in the video on the right, from an impressive installation in the Museum of Modern Art in New York. Also, another aspect of positive impact is that these technologies can create very realistic human-like virtual assistants that are very helpful for learning, healthcare, accessibility, etc. As for example, the virtual signer that you see on the right that can communicate with the deaf in sign language. On the other hand, there are also several concerns and ethical considerations related to these technologies. First of all, artists fear that the developments in AI will make them lose their jobs, but there are also concerns in terms of copyright, environmental impact, misuse of deep fakes, and last but not least, bias in AI image and video synthesis. So focusing on that, text-to-image generators seem to be very prone to reinforcing many forms of stereotypes, as Panagiotis has already mentioned, in terms of gender, race, nationality, class, and other identities, as you can see in the examples in this slide from a recent study. And focusing on gender bias, it seems here are some examples regarding professions. Again, we've already seen such examples. So when this kind of popular AI models are prompted with prompts like scientist, they're giving results as you see on the right. So it's really astonishing that 100% of the results correspond to white men with 0% of women. And the similar trend is for prompts for professions like lawyer. And the other side of the same coin is that for prompts like nurse, the results are all 100% women. And these are just a few examples. And as recent studies have revealed, this trend is really persisting. So in this bar plot, the bars on the right correspond to cases where the AI-generated images include a percentage of women that is larger than the real percentage in the labor market in the US, whereas the bars on the left correspond to cases where the percentage of women in the AI synthetic images is lower. And what we can observe is that typically for professions of lower income, the results, the percentage of women in the results is higher than reality, whereas in the case of higher income jobs, the percentage of women is much smaller, such as, for example, engineer, politician, CEO. In the case of doctor, for example, Panagiotis already mentioned, in the real labor markets, women make up about 40% of doctors, but only 7% of the image results, the static results corresponding to women. So why such bias is a problem? First of all, many viewers may interpret AI-generated images and videos as entirely objective or neutral, and these repeated biased depictions risk becoming normalized over time, shaping perceptions and reinforcing stereotypes. Communities portrayed negatively can internalize these portrayals, creating self-fulfilling prophecies, while more represented groups continue to be privileged. Think, for example, the case with a prompt like corporate leadership, where the synthetic images always generate tall, masculine, formally dressed men. In addition, the homogenization of visual content erodes diversity in creative fields, overshadowing richer and more inclusive narratives. So why is this happening? Why is this problem of bias happening? First of all, as Panagiotis has explained, AI systems reflect the bias in the datasets that they were trained on, and these datasets are created by humans. Also, there is the phenomenon of feedback loops. So biased AI-generated images can become parts of new training sets, perpetuating and intensifying inaccuracies or stereotypes over time. As I mentioned earlier, the internet is now flooded with synthetic images, and these are actually included in the training sets. And finally, a more technical aspect is the so-called bias amplification. So when a bias is present in the data, the model's tendency to generalize patterns in a simplistic manner can amplify that bias, producing outputs that reinforce existing stereotypes at a very large scale. And now, what can we do about these issues? There are several countermeasures that can be taken. First of all, the good news is that there is a growing public discussion, as Letizia already described. And also there are tools that help reveal and analyze the bias in AI image generation, such as, for example, the diffusion bias explorer that you see on the right. There are also several technical solutions that you already heard about them. And also a non-technical aspect is related to including diverse teams in the design and decision-making regarding AI technologies. For example, in 2019, it was estimated that more than 80% of AI instructors were male, and this very large gender imbalance is something that has changed in the following years. So finally, it's worth mentioning that generative AI can play a positive role in gender issues with interactive installations like the mirror diversity that yours and Vivi already presented, but also with shows that go beyond the gender binary, like the ZZ Show by Jay Kells, an interactive deepfake drag cabaret that criticizes the discriminatory behavior of the datasets used in AI. And this is a video from this show.
For the evening, the world's first deepfake drag act, ZZ!
So as this show comments on the fact that computer vision systems have difficulty recognizing trans, queer, and other marginalized identities, and attempts to expose and subvert this bias. So in conclusion, 13 years after the beginning of the deep learning revolution, AI for image and video synthesis has achieved many important milestones, but at the same time, there are many examples of bias in AI image and video synthesis, with gender bias being one of the most important types. And this is actually a persistent problem that is not easy to address. And there have been proposed several strategies to mitigate these effects. However, much more needs to be done towards this direction. And also, there is an urgent need for scientists and engineers in our fields to be more engaged and proactive regarding the relevant gender issues. Finally, on the positive side, AI can merge with art, as I showed, to promote gender equality, while also challenging social structures that reinforce gender inequality. Thank you very much.
Thank you very much. This is yours, right? Thank you all. I will try to be very short. As a member of the Gender Equality Committee and the Anti-Discrimination Committee of Fourth, we have done some work the last few years that was also the motivation of starting all this discussion. I will not get into this very much because Maria, in the beginning of the workshop, she said a lot of things about gender equality and anti-discrimination committee. The role and the scope of the committee is to develop a research and work environment respecting gender equality, promote excellence through diversity, and demonstrating zero tolerance to any discrimination or prejudice based on gender. We have done some work these 3 years. We try to collect quantitative as well as qualitative data for the organization. We try to analyze them, and we try to suggest policies in order to become better concerning the gender equality status of fourth in general. Okay, so why this could be important? I mean, someone that's why we are interested about all this. Okay, first of all, equality and non-discrimination, gender included, is a fundamental human right. So we have to respect it in the workplace, in the research, and in any action we do in our everyday life. Second, there are reports from the Europe that they estimate a shortage in ICT specialists until 2030, that it is quite high. I mean, we have 1.4 million specialists that we will not have them available the next, let's say, 10 years, more or less 5 years. We have similar huge numbers for Greece. They estimate 7.5K per year ICT specialists that we will not have them available. Women represent almost 20% of the ICT workforce. In Europe, the same in Greece. So some numbers for ICS for our institute. If we see here on the higher level, the faculty and the researchers percentage at this level of of position, the percent is below 20%, the female presence. The same holds in the scholars. Scholars are the people that they get some scholarship in order to, they are up to the PhD level. I think I have calculated here also the postdoctoral level with the scholarship. So we have something like 25% in this category of colleagues. As we see in the in contract, we have better percentages, something like 60-40. In contract, most of people do not have a PhD from our staff members. Okay, so we see a gap between people up to a master's degree, and from that point on, higher. So, in summer 2022, we executed a questionnaire. It was sent to all our staff members, all our community, basically, from ICS, from 500 approximately recipients, we received 118 replies, 60 more or less percent, 57% of the answers were by males and 40% by females, and declared non-binary 1.7%. I give here just indicative results. Here is a nice work that we could do. We could analyze further these results, as well as a future work. It will be nice to make the questionnaire better and more focused in order to have more precise results in this area. So the replies on the question, are male and female treated equally in fourth? Okay, we have 50% of the ICS colleagues, okay, members of ICS replied that yes, they agree that they are treated equally. 22% disagreed. And 23% didn't want to answer. To the question, have you personally experienced harassment and or bullying related to your gender or sexual orientation within fourth? This was the question. Fortunately, 90.7% of our colleagues in ICS from the repliers, okay, they said that they have never experienced harassment or bullying. 9.3 declared that they had, yes, they had. This result needs further investigation because in this question, it is included microaggressions. I mean, from microaggressions to much more serious, probably incidents. Okay. And another indicative result is does FORF respond to concerns about gender equality? 43% replied, I don't know. Okay, so this we have to consider. Okay. Now, why this area is interesting, and as we had input from the previous speakers, why we should look closer to this field, let's say. Technological innovation is the flagship of our societies. Everything is digital anymore. So, by whom are digital systems designed and for whom, under whose values and for whose interest? Is the neutrality of digital artifacts questionable? Are digital systems inclusive by design? Could they be inclusive since the design teams are not inclusive? Are there ways to pinpoint, locate, and isolate and eliminate gender or other discrimination bugs during the design phase? Women are underrepresented in computer science field. This is true worldwide. And there is a declining trend, as the bibliography declares. What is the relation of this asymmetry with the social consequences of the digital transformation? Could digital transformation, as Tassos explained, as reinforce discriminations? Okay, the guidelines from the European Union is a three strategic approaches. They motivate us to fix the numbers, so have a more balanced workforce, fix the institutions, promote inclusivity in careers, and fix the knowledge, which is, you know, something that we do here today. I mean, we try to stimulate excellence by integrating gender and intersectional analysis in research. Now, in ICS, how we step forward, we try to follow the guidelines and follow the European guidelines and create our own. How we do this, we closely work and be part of the Gender Equality and Anti-Discrimination Committee of FORF. We compile gender equality plans, and we try to create a gender-inclusive workplace here in the organization. We try also to survey on good practices and learn from achievers. That's why we called Letizia to be here with us today. And we try to set up activities, education, raising awareness actions like we have today, work towards a more gender-friendly computer science field, train more social gender-sensitive computer scientists in our university departments and within FORF, empower females in the field and encourage girls to follow the field, promote inspiring role models beyond the smart and nerd one. Now, our baby steps. We have a collaborative faculty member Professor Panayota Fatourou. She is the chair, I think, of the Greek ACM chapter for women.
Not anymore.
Not anymore. I think she still is.
Is she?
Yes.
Could be. She used to be the president of ACM Europe with South.
Yes. Okay. And a few years ago, something like 5 years ago, she has organized, in cooperation with the computer science department of the University of Crete and with the region of Crete, a summer school for girls in STEM and computer science, promoting STEM and computer science. The Fourth Gender Equality and Anti-Discrimination Committee initiated a couple of years ago the Greek network of gender equality and anti-discrimination committees in research centers and independent research institutes in a nationally wide. So we have an informal network where we discuss all the research centers of Greece. I mean, we meet every month, once every month, and we discuss such issues and try to establish understanding, policies, do some webinars, etc. Community raising awareness events have been organized by Fourth Gender Equality Committee. And we have, a couple of years ago, a small workshop considering issues in Horizon Europe for gender-sensitive research. We made an intervention with this banner in the Researchers' Night this year, in September 2024. There have been published 2 policy papers initiated by our ICS, our ERA chair, Professor Alexis Stamatakis. He's an ERA chair in ICS 4. He collaborated with other highly qualified scientists of Fourth, and these are the links. They are policy papers and suggestions of how we could face the low percentage in professorship concerning females. And today we have this workshop here. Okay, what we could do next? We could analyze a report on qualitative and quantitative data. We can motivate the scientific council of our institute to set up policies for fixing the numbers and fixing the institution. We set up a discussion group to motivate our researchers to get into research in this field. We could design a mentoring program for improving career development skills for everybody, not only for females. We could motivate the management to support work-life balance infrastructures. We should say here that a building is built nowadays, that it will be a caring for babies, a caring place. The building will be here, but we have to operate it. So it's up to us to help and find a way to support families, to create, I mean, this kindergarten, so families and women in research can be assisted with the caring of their children. and work closely with allies in European level and in national level. That's all for me. Thank you very much. Amanda from ICF. So, now I have to close there. So thank you very much. Thank you for participating and hope it was useful for everybody. Nice to meet you all. Thank you.
A lot of things, no? That's big steps.
Big steps you take. Πρέπει να τα μάθετε.
Φαντάζομαι έχει longer version.
Τώρα θα τις βρω. Όχι στο Δήμο. Ξέρεις, να το βαλές.
Κάτι είναι στη θέση του. Πάντα τα χειριστά
Yes. Very experimental and quite strange. But generally, I want to find some additional, some collaboration. This would be really nice to work on that. Yes, yes. So now I have to rush, but see you at dinner tonight. Yeah. So we'll have the opportunity to see you later.
I will sleep for half an hour.
Okay, yes, a power nap,
στο θέμα, και το έχει δουλέψει πάρα πολλά χρόνια. Νομίζω ότι αξίζει τον κόπο.
Λοιπόν, τα λέμε το βράδυ. Όχι, με διευκόλυνες. Εγώ είχα πολλά να κάνεις σπίτι, οπότε ήταν τέλεια.
That's why this kind of process all the time. Yeah.
Ωραία, αυτά θα τα πάω στην γραμματεία μας.
Εμείς κάνουμε στα πεπάτια.
Εγώ θα την πάω.
Ναι. Σε
Now,
ένα τέταρτο όμως τώρα.
What time is the?
9 o'clock, I will pass by and get you with your husband.
Ναι.
Okay? And walk, it's 5 minutes walk.
Where are you staying?
Ibis.
Ibis.
we managed to arrive. We don't need to come. We arrive to the restaurant. But
Have I sent you the pin, I mean the Google Maps, have I sent it?
I don't remember. You can send.
But I can, because it's easy for me to park in the parking.
Of the hotel. Yes, then yes.
Okay, so I will come and go together, okay?
Much again. I hope you enjoyed this
Very much.
series of.
So I was really
Γιώργο, θα
inspired.
έρθεις το βράδυ,
Μάλλον είναι λίγο δύσκολο.
σου είναι δύσκολο. Okay.
Ναι, μάλλον είναι λίγο δύσκολο.
What is δύσκολο?
Difficult.
Δύσκολο. In Italian, δύσκολο is very something else. It's a thing that is not very good. Like Pinocchio was a
okay.
δύσκολο.
Here as well.
No, no.
Well,
Το παιδί είναι δύσκολο.
Είναι δύσκολο.
Οπότε θες να αφήσεις εσύ απόψε.
Όχι. Δεν θα. Δηλαδή ούτε εγώ. Θα είμαστε εκεί.
Γιατί ήμασταν 8, ήμασταν 7.
Τι ώρα.
9 ώρα. Θα πάμε μαζί.
Εντάξει. Πώς κλείνω μια ώρα.
Okay, so I'll see you tonight. Thank you very much. Thank you.
Thank you. See you tonight. Let me, there are a lot of things to.
Yes.
μα έδωσε το τηλέφωνο σου, αλλά
Να φέρνω το σήμερα.
στο απειλή θα πάτε.
Θα πάμε στο σπίτι. Εδώ,
Να φέρω και το μεσί.
όχι. Είναι σχεδόν βέβαιο.
Όχι, νωρίτερα.
Δεν ξέρω τι θα γίνει στο record.
Όχι, Μάγδα, ήταν Μάγδα. Όχι, στο τηλέφωνο σου δεν θα με έχεις. Νόμιζα ότι κοίταγες στα mail σου.
Α, μου έχεις δώσει το τηλέφωνο.
Δεν ξέρω. Γράψτε, Letizia Jaccheri, 69-32, 02. Και κάνε μου και μια κλίση να έχω και εγώ το δικό σου.
Μπράβο. Νομίζω μια χαρά πήγε. Μπράβο, Μαγδαλίνη, να σου πω.
Μπράβο, Γιώργο, ήθελα να σου πω και εγώ. Βλέπετε αυτό το ωραίο project.
Ναι. Που τελειώνει. Πρέπει να βρούμε.
Πρέπει να βρούμε άλλο.
We need to find another one. This is the discussion.
George, it was a deadline. It is a deadline now, early March for